welcome to Agora Math Circle's Senior Beginner Lecture No video. My name is Joe, and today we are going over angles. So we're going to look at measuring angles, parallel lines, and finally angles in polygons. So here are a bunch of important figures to know for measuring angles. First, we have a point, and that's just a dot on the paper, or dot in space. So this is labeled with a capital letter. So this right here is called point P, with a capital P. Next, if we have 2 points connected with a straight line, we have a line segment, and we can label it with the points. So this would be line segment AB with a bar on top. Next, if we have a line segment that continues on forever on both ends and doesn't stop, then we have a line. So we can call this line AB with a line and 2 arrows on each side, or we can call it line K with a lowercase letter on top of the line. Next, we have a ray. So this is a line segment with one side continuing forever. And we can label it ray AB with an arrow going to one side. Next, we have an angle. So an angle is just 2 rays connecting at a point that's called the origin. And the origin right here is going to be point O. So we can call this angle, angle A, with a lowercase letter, put on the inside of the angle. Or we can call it angle O, since O is the point of origin. Or we can call it angle XOY. And we're putting O in the middle since it's the origin, and X and Y at the ends. So next we have intersecting lines. Right here we have line AB and CD that intersect at point P. Now we can't call any of these angles angle P because we don't know which angle that we're referring to. So we instead label it like this. This angle right here would be angle APD. This angle would be APC. This angle would be DPB. And this angle would be BPC. So to measure angles, we use a protractor. And a protractor measures about half of a circle. So if we divide half of a circle into 180 little pieces, each piece is called a degree, and that's how we measure angles. So if half a circle is 180 degrees, then a full circle, which is 2 halves, is going to be 360 degrees. So here are some important angles to know. A right angle is always going to be 90 degrees, and it's going to look like this. And we can use a square to show that it's 90 degrees, a little mark right here. Next, we have acute angles. So an acute angle is going to measure less than 90 degrees. Right here is an example. And as you can see, it looks smaller than 90 degrees. Then we have obtuse angle, which is going to be greater than 90 degrees. As you can see here, this obtuse angle is greater than 90 degrees. And then finally, we have a straight angle, or just a line, which is going to measure 180. You see right here, you can label it with a half circle. So let's look at some properties of angles and lines. So supplementary angles are 2 angles that add up to 180 degrees. Let's look at these 2 angles right here. So we have angle A and angle B, and they both add up to 180 degrees. As you can see, it's really just a straight line that's being cut by another line, or a ray. So then, if we just cut the straight line into 2 pieces, they both are going to add up to 180 degrees. Same right here. We see the straight line, and we see the 2 pieces that it's cut into. Angle A, angle B, and they both add up to 180. Now each angle is going to be called the supplement of each other. So A is a supplement of B, and B is a supplement of A. Next, we have complementary angles. These are 2 angles that add up to 90 degrees. So you see right here, we have angle A, and we have angle B. If you add them up, we get a right angle, or it's equal to 90 degrees. If you look right here, angle A and angle B, and if you add them up, you get a 90-degree angle. So you can just see that it's a 90-degree angle that's being cut by a ray. So 2 pieces add up to 90. And so just like how we refer to each other as supplements here, we refer to each other as complements here. So angle A would be the complement of angle B, and angle B would be the complement of angle A. So here are some more properties of angles and lines. Vertical angles are angles that are opposite each other and have the same measures. So if you look at the intersecting lines of CD and AB, we see that the vertical angles are APC and DPB, and CPB and APD. So these 2 angles are vertical of each other since they're opposite of each other, and they have the same measures since vertical angles always have the same measure. Also, these 2 angles right here are opposite each other, so they have the same measure. Now they might not have the same measure as this angle, but they will have the same measure as each other. So congruent angles are angles that have the same measure. So you could say that vertical angles are always congruent angles. Next are adjacent angles. So adjacent angles are 2 angles that share a vertex and a side, or just simply 2 angles that are next to each other. So if you see right here, angle APC and angle CPB are next to each other, so they are adjacent. Same with angle CPA and angle APD. They're right next to each other. They share a vertex and a side. Next, we have perpendicular angles, and that's when two lines, rays, or line segments form right angles. So we see right here, we have two lines that form a right angle, so we get perpendicular angles. So now that we know the properties of angles and lines, let's try to apply those into these example problems. So first, we have these two angles right here, angle A and angle B, and they both add up to 90 degrees, as shown by the square right here. So we know that angle A is 40 degrees, and we want to know what angle B is. So since we know that they both add up to 90 degrees, and we already know what angle A is, we can just do angle 90 degrees minus angle A to get angle B. So 90 degrees minus 40 is going to equal 50. So angle B is 50 degrees. And we can check that by doing 50 plus 40, which equals 90, which is correct, since they both form a right angle. So in the next example, we have the intersecting lines WX and ZY. And we only know the measure of this angle right here, 61 degrees. And we want to fill out the rest of the angles. So since we know that vertical angles are congruent, or they have the same measure, we know that this angle is going to be the same, 61 degrees. Next, we're going to use our supplementary property. So since we know that this is a straight line, it's just being cut by a ray, or a line right here, we know that this angle right here is going to be 180 minus 61. So 180 minus 61 is 119 degrees. 119 degrees for this angle, and then the vertical angle, or the angle opposite to that, is going to be the same measure, 119 degrees. So now let's move on to parallel lines. So parallel lines are two lines that will never meet or intersect. So these two lines right here, line AB and line CD, are parallel. They're never going to meet or intersect at any point ever. So we say, we notate it like this. Line AB is parallel to line CD, two lines. So a transversal line is a line that cuts through parallel lines. So if you see right here, this line right here is being cut through by this line. And the resulting angles are right here. We have AD, BC, and then we have WXYZ. Now a really cool fact is that these angles are always going to be the same measure. A is always going to equal C, and W is always going to equal Z. And these are all going to equal each other. And then D is always going to equal B, and X is always going to equal Y. So to see if this is true, let's try it with some actual numbers. Let's say that angle D is going to be 20 degrees. So if angle D is 20 degrees, then how much would angle A be? Well, it's a straight line, and we know one angle, so they're supplements. So we know the supplement of this angle is going to be 180 minus 20, which is 160. So now that we know this angle, which is 20, we know that the angle that is across from it, or vertical, is going to be congruent. So we know that this angle is also going to be 20. And we know that this angle is also going to be 160 degrees since they're vertical. And since we know that this is pretty much just being copied right here, we know that it's going to be the same for all of these. This angle is going to be 20 degrees, this angle is going to be 20 degrees, this angle is going to be 160 degrees, and this angle is going to be 160 degrees. So next, let's move on to angles and polygons. So a polygon is a simple closed figure made of line segments. So when we say simple, we mean that there are no intersections in between the figure, and closed means that all the lines connect. So these right here are polygons. A square, a triangle, a pentagon, this shape right here, since none of the lines are intersecting and none of them curve, and it's a closed figure, it's a polygon. And here we have an octagon. So these are not polygons. A circle is not a polygon because it's not made of line segments, it has curves. Also, this figure right here, it's like a rounded square. There is no line segments, it's curved. This right here it doesn't close, so that's why it's not a polygon. And this right here has an intersection. Now, if we take away one of these triangles, then yes, it will be a polygon, but since it intersects, it's not a polygon. So, here are the parts of the polygon. When two sides intersect, we have a vertex. Here we have a side, which is obvious. And here, the angle inside is called an anterior angle. And then when we connect one vertex to another vertex inside the polygon, it's called a diagonal. So regular polygons are types of polygons where all the sides and angles have the same measure. So a quadrilateral is a special type of polygon that has four sides and all of its interior angles equal to 360, or they sum up to 360. So here we have a square. And since we know that each angle inside is 90 degrees, we know that all of the anterior angles sum up to 360 degrees. Next we have a rectangle, and the same thing. 4 sides, anterior angles add up to 360. Here we have a parallelogram. Now if we measure the angles, we'll find out that these two angles are congruent, and these two angles are congruent. And when you add them all up, they add up to 360. So next, let's look at triangles. So a triangle is a polygon that has 3 sides and has all of its anterior angles sum up to 180 degrees. So let's look at 3 types of triangles based on their angles. First, we have right triangles. So a right triangle has 1 right angle in it. Next, we have an acute triangle. An acute triangle has 3 acute angles. Now in this triangle right here, we have 3 equal acute angles. So that means that this triangle is also called an equilateral triangle. Not all acute triangles are going to be equilateral triangles. So next we have an obtuse triangle. So here we always have 1 obtuse angle. And then these sides right here, these angles are different. So let's move on to other polygons. Now if we want to find the sum of the interior angles of an n-sided polygon, we are going to use the equation 180 times n minus 2 equals the sum of the interior angles. So n represents the amount of sides the polygon has. So next, let's look at exterior angles. So the sum of the exterior angles of any triangle is always going to be 360. That's always going to be the rule. So make sure you remember that when you do your problems. So thanks so much for watching. I hope you enjoyed the video and learned a lot. Don't forget to like and subscribe. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!